Again, my name is Paul, and I work at Connector Lab. Um, Today's topic is on iOS reverse engineering. I am by no means an expert in this topic, and I really appreciate this opportunity for me to share with you what I've learned so far and what excites me to learn more in the topic of reverse engineering. Before we get started, let's get a couple things out of the way. The app we're looking into today is something I put together really quickly. And in order to facilitate the flow of the talk, I have to make some more of a contrived code, but we'll cover some more of that later. Did I mention Connected Lab is hiring? I will edit the Google Doc. Thank you very much for putting that together. That should do. Without further ado, should we first, whoa, what is that? Should we first take a look at our victim of the day? That's the app we will be reverse engineering today. It's called I'm Locked. And as you can see, it's a lock screen that requires a 4-digit PIN to pass in order to proceed to the rest of the app. And you might have noticed on the top right corner, there's a counter for attempts. Let's put in something random to see how it goes. 0, 0, 0, 0. Oh, thanks. Hello, hello? Oh my God. I can hear myself. Yes, so putting in a PIN number that is not valid would not let you pass the lock screen and also decrement the attempt count. And our objective today is to bypass this screen and to gain access to the rest of the app. We will make hypotheses as we go, and we will validate them and invalidate them as we proceed. So my first hypothesis is this app must communicate with a web service that lives somewhere in order to verify the PIN. How do we validate this hypothesis? We can definitely inspect its network traffic. And correct me if I'm wrong, since iOS 9, Apple pushes for app transport security, and all the traffic preferably will be going through HTTPS. That makes a headache for us to inspect encrypted network traffic. One thing we could do here is, of course, we can have Charles proxy set up, and essentially that will launch a man-in-the-middle attack between the app and the web server it talks to in order to inspect what's going down the wire in plain text. That requires setup. And let's put ourselves in the shoes of a reverse engineer. The data that's being sent down the wire is encrypted in the network layer with the SSL certificate. What if we take a level up and at the application layer, all the data must be in plain text before they're sent down to the network layer? And what if we can load up a dynamic library into the process that's currently running on the iOS device, and that dynamic library will method swizzle, let's say, the NS URL session and NS URL request to log its arguments? Wouldn't that get us the payload of the traffic in place? My apologies. It's already been done, and if you want to do it on your own, you might need a jailbroken iPhone in order to load dilibs into a process. But what we're doing today is that we're going to use a tool called Flax. That's a debugging tool written by Flipboard. It does a lot of things. It shows you the view hierarchy of the app. It shows you the file system inside the app sandbox. And among all the features it has, one thing is it does a networking traffic logging. So let's turn that on for the app. There's a tweak already. You can download from Cydia. You just have to flip that switch to enable flags for I'm locked app. We'll have to kill this process in order for the dilib to work. We'll open up the app again, and you'll be presented with this little toolbar here. We'll go to the menu, and the first item in this table view, in this list, is network history. We just have to turn on the network debugging, and let's try a couple more random pin to see if this app actually sends any data down the wire to communicate with this server. Let's try something 1, 2, 3, 4. That didn't work. Okay, that's 2 attempts. Let's go back to network history, and we can see two network requests. But if we drill down, looking at this request URL, you'll see it's sort of sending traffic. It's sending a request to Google Analytics. That is not what we're looking for. What about the other one? There is also a Google Analytics request. And that's all the network requests that the app sent during the time that we input the 2 pins. So at this time, I think I can confidently say this app does not use a web service to validate the pin. So my second hypothesis would be, how does the app validate the passcode? It must have stored it somewhere in the app. Could it be the app bundle? It could be in, let's say, the file system. Would it be in the enhanced user defaults? Could the data be stored inside the keychain? And what we're looking for is probably either a 4-digit numeric string, or it could be a hash string of some sort. Let's go back to Flags and see what we can expect with Flags. We see the file browser. Nothing is really interesting in the library. There are 2 files in the cache, not much going on. In Flags, you can inspect the NS user defaults, the standard one. There's a lot going on here, but I will show you there's nothing in there. There's really nothing really interesting that Flags can show us. We gotta dig a bit deeper to see what the app has in its app bundle. That will require us to SSH into the device. So I've connected my iPhone and my MacBook to the same network. I'm just gonna quickly SSH into my iPhone. Whoops. And we're in. Let's find out where this app lives. We know it's running as a process now on the iOS. We can, if we do a, how do you call this? If we look for the processes that's currently running, we'll see a lot of them. Can we narrow them down? We know all the Apple's apps are living in this directory. And you'll see a lot of familiar faces, like the mobile notes. You'll see camera. You'll see a bunch of the apps that Apple built. But these are not what we're looking for. We're looking for the third-party apps that either was installed from the App Store or you installed yourself from Xcode. So they all reside in this directory: containers, bundle, and application. However, you see a lot of folders that's named with UUIDs, and let's go into one and see what they have. You see it's an app that I installed myself. That is indeed something we're looking. This is the right place to look for the app, for the our app today. However, this is not the very directory. So now we can run the same process, ps command again, and we'll just do a quick grep on the directory to help narrow things down. We're seeing two things are running. One is I'm locked, the other is iBeacon. That's probably irrelevant. This guy looks really suspicious. That's probably the one we're looking for. How do we verify? What if I try to kill this PID and will our app survive? And will Wi-Fi allow me to do this? Bear with me for a second. Let's see that again. var container, and we get the UID, and let's try to kill it. Okay, so thank you. Sorry for the suspense here. So this is the one. This is the process we're looking for. Let's launch that again. So we know exactly where this guy lives at now. We know it's right here, and we'll CD into its application bundle. My apologies. Just bear with me for a second.
You could do a little dance number
Whew. I'm sorry?
Clearly, it wants you to run terminal app from on.
Indeed. That could have worked better. Oh, okay, here we go. Wow, okay. Does it help if I should try that? Let me try start a new SSH. Okay, do I still have, nope. Can I still copy over the path? Okay. Or no? Whew.
Copying more than just the previous path. Yeah. You have part of the prompt command too.
I'm sorry?
You look at what you're pasting more than just the original path. You also copy part of the prompt from your terminal.
Oh.
That's why you're in application, it doesn't go any further, but you can just tab complete 26690.
That's a good idea. Let's do that. Yes. Thank you. Okay. Whew. Sorry, we're finally here. This is the this is the app bundle of the app we installed, the I Am Locked app. So as you can see, we have a lot of image assets for the icon. We have compiled the compiled storyboard and a bunch of frameworks. And if we drill down to the frameworks, we can see the frameworks that this app is using. I've imported RX Cocoa and RX Swift and a bunch of dilibs that the app will require for it to run. Go back up a level. You can see the I'm Locked app binary. And one other thing that's rather interesting is the info.plist file. If we use the plist util to see what's inside, you can find out all this information about the app, the bundle ID that you can, whoops, maybe I'll, util, I'll pipe it to something else to see. You can find the app's bundle ID. You can find if there's any URL the app uses in order for other apps to deep. Oh, it doesn't have. Never mind. Sorry. Any URL that the app could be using for other apps to deep link into it, or any URL this app uses in order to handle a file type. So we've looked at this file structure, this app bundle, but it doesn't seem to be containing anything of interest. We still have one place that we haven't checked yet that's inside of the binary. What if that, let's say, 4-digit pin string or the hash string was hard-coded and compiled into as a part of the app binary, and that would definitely be somewhere in here. So I downloaded that just minutes ago onto my laptop. It is this file, which is a Mac O executable built for a 32-bit iOS device. If we run a strings command on it, it should retrieve all the strings that's embedded in the binary and see if we can find something suspicious. I think the first line looks kind of like a hash string to me. Do you think? So it's not really a plain text. It's a hash string. And we don't know what hash algorithm that was used to generate this string. We could take it and try to reverse it. That's probably going to be quite time-consuming. So it seems like we've sort of hit a wall here. We're sort of stuck. What else can we do? For so far, we've been passively observing the behavior of the app, and we're inspecting every corner of the app to see if there is any angle for attack. What if we would change our strategy and take a step further so that we're altering the app behavior for it to do what we want it to do? And we need some more knowledge, more insight to back up what we wanted to do to alter the app's behavior. So first thing we can do here is to dump the header files from the binary. So now we have the binary here. I had to compile this class dump myself because the original one doesn't support Swift headers, Swift files. So we'll quickly run class dump on the app binary, and it will output everything in the current directory. And that might be a small o. Yes. A couple files were exported. I actually created the Xcode project so we can look at them with syntax highlighting. Let's open that up. So can we see? Is there any way I can make it better? A bit better? We have a couple header files exported. The very familiar app delegate, lock view controller that sounds very much like the lock screen that we saw. It had a couple files because I was probably using Swift extensions, and they were exported as categories in here in Objective-C. And we see another file, a couple UI collection view delegate that probably is the view that the attempt count was using. And there's another class that's called view controller. So digging deeper into lock view controller, we're seeing one of the things, we can look at its IVARs, and we see there is one IVAR that says attempts left. I am suspecting that this is tied to what we see in the attempt count at the top right corner of the app. And let's see if there's a way for us to access the IVAR. And the reason why first to do it is something that is preventing us to brute force. Let's say it has a legit attempt count, and the phone will explode when the count drops to 0. So that one thing that's preventing us from brute forcing the password would be the numbers of those dots left on the screen. But what if we have we're taking 4-digit pins here. What if we can make the attempt count to, say, 10 to the power 4? Then within a couple hours, we can pretty much brute force this 4-digit pin number. Let's see how we can do this. We'll be using this tool called the script or Cycrypt. That is it uses a hybrid syntax of JavaScript and Objective-C, and what it does is that it loads itself. It itself is a dynamic library. It injects itself in the running process of an iOS app, and it gives you back a REPL environment so that you can poke around, change values of variables. Let's see how this works. Now we're back on in the secure shell of the iOS. Now we know the app is called I'm Locked. So let's launch crypt and passing the name of the app. It could take a name or it could take the PID of the currently running script. And here we are. We're in the REPL environment. So one entry point that we have is the UI app. It's a shortcut in order to grab the pointer to the UI application. So UI application would have a key window. That's the window that's what we're seeing right now. And if I print out the recursive description, I'm pretty sure I spelled this wrong. Description. And cast that to string. That should print out the view hierarchy of what we're seeing now. So we're seeing a UI window. We're seeing a UI view that's as big as the screen. So that's probably the main screen we're looking at. We're looking at a UI image view that is also as big as the screen with a little bit offset top edge inset. That's probably the background image. And we dig a bit deeper, we can see all the UI labels and so forth. Script is very powerful. Let's say I'm really annoyed by the background image here. I will be able to, we have identified the pointer to the background image, and you will be able to grab the instance of it. Let's say this is the background, and you can just use the hashtag to pull in the instance from the memory address. And I think that background image looks terrible, and let's make it, and with Objective-C syntax, you can set it to be hidden, let's say. Or sorry, it's yes, isn't it? And that hides the background image. Now I can't see anything anymore. Let's go back to the the view we were just seeing, and let's see if we can set a background color to it. So let's grab that same view. Whoop, I did not copy the pointer. And we'll make it background color is UI color. Let's say black color. Is that what it looks like in Objective-C? Is there brackets? There's no brackets. Oh yeah, there's no brackets. So yeah, as you can see, script it gives you the power to really poke around and do and access the variables and the instance variables and invoke methods of an app, a running app in a REPL environment. So let's get back to what we were doing. We were looking to extend the attempts of the app, of the tries. So first of all, let's grab a reference to the current view controller we're looking at. One thing we could do is that we know this is a screen we're looking at. This UI view must be the view that's being driven by the UI view controller. So let's grab that again. We have the view. We have the view here. It's the same view. What if I call view.nextResponder? That should go down the responder chain and grab me, supposedly, the view controller. Here it is. Let's assign a handle to that. If you use the star syntax here, you can supposedly look at all the IVARs inside of the view controller, but somehow it's always been cutting off for me, and I couldn't find what we just saw in the header file. That's attempts left variable. So let's just access that. Attempts left. Attempts left. And let's see what its current value. Maybe still thinking.
That's a good point. On your phone, is the cursor still flashing?
What cursor, sorry?
The cursor in the, it's back to flash.
Oh. Was it because my phone was locked?
Well, Carl pointed out that it stopped flashing.
Oh, I see. Okay. Now do I see things here? Next responder. Okay. So do we still have our view controller? Yes. Dot attempts left. Should I just keep my phone alive? Attempts left. Sorry, I missed the S. That prints out 5. That corresponds to what we're seeing here. What if we make it 10? And let's see what it has in there. It says 10, however, we're not seeing the view being updated, only the model. So let's see if we can grab a handle to that collection view controller and see if we can force a refresh. We might still have to do .key window. Hello. Recursive description. Let's find that collection view. Here it is. And it's only 30 points tall. That's probably exactly that the attempts counter is. So let's grab a handle to that. And let's call reload data on this guy. Once the data is reloaded, you'll see all the view is also updated too. So let's say we make it 10,000, and there's probably a chance we could figure out the passcode. But that sounds like a lot of work. What if we saw just now in the header file, there's this thing called view controller. That sounds like that's probably the rest of the app. And there's one function that is conveniently called view controller. I wonder what that does. Let's try to first grab the class, grab that class from our running process. Because Swift uses the module name dot class name notation for each class, we have to do a couple of things that's sort of different here with script in order to get that. Well, let's say this is the view controller, let's say, class. So Objective-C, get class. And we're passing this string that's I'm locked, which is the module name, as well as the class name, view controller. So that is the class. The method we just saw is a class method. What if we call that method on the class? Oh, here it is. That actually gives back an instance of the view controller, which is the rest of the app past the screen. Let's grab the reference to that. And now we have a handle to the next view controller. We can present it by assigning UI app. In the key window, there's a root view controller. And what if we assign the reference to that root view controller? And that actually bypasses the pin, the lock screen, and proceeds. Sorry for the cheesiness, my bad. But, thank you. Cheesiness aside, that allows us to bypass the lock screen and proceed to the rest of the app. How am I doing for time? Am I okay? There are a couple other things I would love to show you. There's another thing I was thinking is that we can see in the lock view controller that it has a is valid function. That sounds like this function is used to return true or false regarding to your user input to verify the PIN numbers. What if we can do exactly what script was doing? Can we write a tweak that gets compiled into a dynamic library, load that dynamic library inside your iOS, and all that does is just method swizzle that one method called is valid and only return true. With that, doesn't matter. It wouldn't matter what pin you put in the app. It will always allow you to have access to the rest of the app. I think that could be for another day. We would be using a tool called Theos. That is a universal makefile system that allows you to write tweaks and gets compiled into a dilib. Just to quickly wrap up before we end the talk today. So we've looked into app bundle. We've inspected every corner of the app to look for the information we're looking for. We looked into the tool called Flax and Script, and we were able to alter the app's behavior with Script at runtime. So what do we not cover? We didn't cover Theos. That's for the tweak writing. But also we didn't cover things like disassembler, Hopper, or IDA, although I tend to call it IDA, but it's probably IDA. We didn't look into launching a GDB and get that hooked into our running process for debugging, setting up breakpoints, and going down one line by another to see how to gain more insight of the app. We haven't covered any security topics like string obfuscation. We didn't talk about, say, SSL pinning that would prevent man-in-the-middle attack that we were about to do with Charles Proxy. And we didn't talk about maybe securing a web service that works with iOS app. I think those things are something I'll be looking into next thing myself. I'll keep you guys posted when I have an update. And that's all I have for today. Thank you very much.